this one, yeah. So 3 weeks ago, we hosted the OpenClaw meetup in San Francisco, 3 weeks ago. And since then, IronClaw was born. It was like a small experiment. It kind of blew up, and so every night he started building and fixing stuff every night. And it's very exciting how it became to be how it is right now. And it has a lot of potential. So I'm really excited to share an update on IronClaw and introduce Illia to the stage. There's a big round of applause for Illia.
All right, thank you. I'll try to catch us back on time, so I'll give a quick rundown here. So for those who are not familiar, I'm one of the co-founders of Near Protocol, Near AI, Near Asterix things. Before that, I was actually an AI researcher. I was at Google. I was actually working with Lukasz and the team on transformers, question answering, and lots of other things. And so one of the things that has happened over the past 6-7 years is that AI effectively came back from being a back-end feature that a bunch of researchers in the lab are kind of experimenting and running A/B tests without people even knowing, and being used in Google search, your recommendation engine, Amazon, and a few other things, to first being a chat that you can ask questions and get information directly, to now taking action, right? Being able to go in directly, book flights and hotels, figure out how to pay bills, really kind of executing actions in real life. And what we see even further, and we just had some of the glimpse of that as well, is that these agents are starting to actually coordinate with each other, start to figure out how to do tasks together when they don't have skills, access, or APIs to do it themselves. And so we kind of seen this transformation from this being just a tool to being effectively an economic actor that can execute things on your behalf, can coordinate with other economic actors, and effectively kind of create new level of economy. Now, this means that everything we've built so far for people is effectively getting compressed into something that agents can use, right? We use applications and we have browser tabs. It's a highly inefficient, right? I mean, feeding effectively a bunch of HTML into your agent is just wasting tokens. There's a bunch of tricks to simplify that, but the reality is it just wants to express a very simple intent and get the result. It doesn't need to read all the same rendering and pretty CSS that we got used to. We're used to filling out forms, jumping from one application to another that has no context about us, and kind of really refilling all this information. Bunch of messages, emails with invoices, bills, if you're in corporate environment, continuously processing all that manually. And if you're in crypto, right, crypto was supposed to solve a lot of these problems, but kind of still didn't deliver, created fragmented experience, requires you to understand private keys and RPCs and wallets and connecting things. It's all very complicated, right? Agents really are here now to be your front end, to be the interface with which you are gonna interact with computing, be that the financial part or non-financial part information as well, and really have this kind of easy interface to interact. And so you need a native infrastructure to do that. You need a way to effectively express this and negotiate, find the right solution for yourself. You need the Rails, kind of the common platform on which you can do this, and you need confidentiality, you need privacy, because we're moving from just some aspects of our life to effectively putting all of our context, all of our information, medical, financial, family history, your therapy sessions, all of this is going into one place, and so privacy becomes extremely important. And so I'm sure people here have seen OpenClaw, extremely exciting because it really showed us that, hey, these models are able to do all those things if you give them the right tools. But the challenge is, as you give them those tools, it's also really easy for somebody else to convince them to give all your information to a third party, right? And I'm sure people have seen on internet people getting hacked. Somebody's emails were all effectively deleted by the claw because compaction happened. There's a lot of different challenges that are happening because the system is not built for safety, security, and privacy. It's really been just a really exciting experiment. And so one of the things that we're bringing from our blockchain experience is really like, how do we build with effectively expectations that everybody else is trying to attack you, right? In blockchain space, when you're building something, you're effectively assuming you're in dark forest, the three-body problem reference, where there's, if you reveal yourself, you're gonna get effectively attacked. And so how do you actually create a system that is protecting the user, protecting your data, protecting the information, protecting the system itself? And so this is what we're trying to do with IronClaw. We just released it a couple of days ago, ironclaw.com. It's effectively a hardened version of OpenClaw. It's written in Rust. It uses a number of systems to secure it. I'll talk in a second. It's open source project. Please contribute. There's a lot of things to build. It's still in alpha and needs a lot more work. But kind of the core goal, core motivation is really how do we make sure everything's private, make sure it's kind of clear, auditable. If you want to use it in your company context, in your corporate context, you're actually able to do that, right? Your IT department will not like scream at you and effectively ban you from accessing everything. Make sure everything is defense in depth, and at the same time, it's able to actually acquire new skills and capabilities like OpenClaw has, and effectively expand what you can do with it over time. So just to name a few interesting things that it already has. So importantly, coming from blockchain space, one of the main things is how do we secure execution of third-party code, right? People want to build applications. We want to make sure they don't lose money, that other people don't lose money. And so for 7 years, we've been hardening our sandboxing environment based on WebAssembly. WebAssembly is what runs in every browser in the world. And we're effectively using the same tech to run tools and kind of custom execution for these agents as well. It also means you can actually let the agent build the tools, because even if it messed it up, it still runs in a sandbox, and that effectively doesn't escape the sandbox environment. All the credentials are encrypted, stored outside of the main loop, and never touch LLM. That's another thing. Right now, if you're using OpenClaw, you're literally feeding all of your credentials to LLM provider. Somewhere in logs of Anthropic and OpenAI right now, effectively everybody who used OpenClaw's Gmail access, all of your private information, probably private keys, etc., all somewhere in the logs can be queried out. Those are not encrypted databases either on those sites. So fully encrypted, never touches LLM. There's a policy attached to every credential. If you have a Google credential, it should never go to a non-Google domain, right? If you have a Telegram, WhatsApp, those credentials should not go to third-party domains. So even if something else broke, right, this policy will check that you're not sending this information anywhere else. You have prompt injection prevention. This is a hard topic. This is a continuously evolving battle. That's why you need all of our other checks as well. So even if that gets broken, that is still possible. Ideally, we want to have like small language model that runs for prompt detection, injection detection. All of the memory, so again, for those who are familiar with OpenClaw, it uses file system as effectively its playground. The problem is, as easy it is to access files, as easy it is to mess up your whole file system, right? It's and rewrite itself and maliciously leak all the information you have on your disk. So all the memory is actually in database. The access for the IronClaw is virtualized. It feels like it's on file system, but it's actually fully in database, effectively abstracted out from your real operating system. It supports hybrid search with effectively full text search and embedding search, and there's like a few other tricks there. So really enabling way more richer access through that, and again, not needing to like reindex your file system. Heartbeats and routines, so you can set up like, hey, every morning send me an update on tech news, or give me like in the evening at a moment for reflection, ask me some questions, and then summarize my day. So you can set up those things. It supports web, CLI, Telegram, Slack, Discord, kind of WhatsApp, ways to communicate to it. So you don't need to actually go to the same place all the time. We're working on a little bit more enterprise features, which is, well, first of all, audit log in enterprise. If something goes wrong, they want to know why this happened, and so there needs to be a place where you can find literally everything that happened. So it exists in the first version, but needs to be strengthened. And then policy, right? So what does this mean? Your agent may still do something stupid, right? These LLMs are non-deterministic. There's a lot of context, a lot of memory. And same as employees sometimes do something stupid, right? And so that's why we have policies that people should know and follow. And here the cool thing is we can actually, because we capturing every outgoing action and effectively verifying it already for credential extraction and for other kind of activity, we can also verify it over actual text policy. So you can have your HR actually provide a policy that says that this agent should not, for example, swear in public communication, right? So you can actually have like a proper system for example, in your company to use this to ensure that the communication and actions are following the right modalities. Few kind of high-level architecture, as I said. So we have Wasm tools. We also have a Docker sandbox for more kind of long-term runs. This is all kind of being orchestrated by a trusted core, and then all the credentials and policy checks are effectively fed there. So literally, Wasm tools and Dockers don't have direct HTTP like internet access. They need to go through this pipeline to verify that everything they do is correct. And as I mentioned, right, we have kind of routines. We also have sub-agents effectively running jobs. So when you're scheduling a routine, it actually spins up a sub-agent that runs in its own container. And you can have, hey, like go run this job, do this analysis for me, and then come back with results, right? So you can kind of keep spawning them off and running them in the background as you're doing things. So a lot more work. I mean, this is kind of high-level architecture. There's a lot of contributions. Obviously, like you can use your favorite LLMs, but we're also offering confidential hosting. Pierre will talk more about how this all works and how you can use it in your day-to-day life. And I'll just mention marketplace for agents. Your agent cannot do everything. There's other people's agents who have skills, who have access, who have information, who may have actually people. We are discussed yesterday to bring some robots as well. So you can hire actual robotic bodies in San Francisco to do stuff. It's very cheap, $200 an hour. But this is a marketplace where you can actually connect your agent and start effectively transacting with other parties, agents, etc. Check it out, IronClaw on GitHub, agent.near, and ironclaw.com for the website. And happy clawing.